Hi, this is Mrs. Gustafson, and this is our lesson for 12.1. I have a short warm-up for you guys. Take a look at these. We're going to use the FOIL method to make sure you don't forget about your insides and your outsides. So if you would pause the video and try maybe a couple of these, the first three, and then I can show the answers in a second. All right, thank you for pausing the video. Let's talk about how to multiply these out. So taking a look at question number 1, what you're going to be doing is you're going to do first, which gives you your x squared, and then your insides and outsides give you 2x plus 3x, which gives you the 5. And then your last 3 times 2 is 6. So number 2, again, your first and your last will give you the 8 and the 16, and then your insides and outsides will give you the negative 8. If you tried some of these other answers, this is what you would get. Doubling the 5, so you'd have 5x and 5x for 10. Doubling the negative 9 for negative 18. So today's lesson is lesson 12.1, tangent lines. Please make sure you have your packets for today, and I do expect you to take notes. There will be a hidden symbol within our lesson today that I would like to talk to you about when I get back. A tangent line is a line that intersects a circle in exactly one point. So notice how in this example, point B is the point of tangency. I can draw another line that touches only once. I could draw another line here, but as soon as I go inside of it, that is no longer a tangent. So it can only touch in one location. Point of tangency. Here is a theorem. Theorem 12.1. You will never have to remember the actual number on it. Just remember what it says. A tangent line is always perpendicular to the radius at the point of tangency. So if we go back to that other example, if I found the center of this circle and I went and connected my radius to point B, that would form a perpendicular line. So maybe if I get a little more accurate here, this looks to be the center, and then if I draw that out, there is my point of tangency, and I see a right angle, which makes it a point of tangency. The second thing we're going to look at is if two segments from the same external point are tangent to a circle, then they are congruent. So in this example, point B touches A at a point of tangency. Point B connects to C at a point of tangency. We know that because of this right angle. Then what happens is the length of these blue pieces ends up being the same. So we get a right angle, and then therefore if 2 points touch at a right angle, then they form congruent pieces. So looking at this example, again in red I have a radius, and this central angle is 117 degrees, which means this intercepted arc would be 117. It says, what is the value of x? Well, looking at our shapes, I can see a four-sided figure inside of there. So these two sides would be the same. And then it says they are tangent. So this is a 90-degree angle and 90-degree angle. So then these two sides are the same. We end up forming a kite. And within a kite, we have one pair of angles that are congruent, and in this case, those are both 90. And then these opposite angles are then supplementary. And if you didn't remember that, we know a four-sided figure ends up being 360. So if we subtract off our 117 and we subtract off the two 90s, we would be left over with our 63 degrees. And that's all because this thing formed a kite, which goes back to our theorem on the previous slide that you did not have. So you have some room on slide number 2. Maybe you want to pause the video and draw this picture, making sure to notice that point A and point C are a point of tangency. And the whole purpose of that is to show that AB and CB are congruent. Continuing on our next example, it says find the value of x. Lines that appear to be tangent are. So I think this looks like a point of tangency in here. So if I highlight this, I believe I see some kind of triangle. we remember at a point of tangency that forms a 90-degree angle, so we have a blue right triangle. So using the triangle sum theorem, if this is 90, we have 90 degrees left over. So we subtract off 36 degrees, and that missing angle is 54. Pause the video and try the first example. So again, in this example, we see a point of tangency. So it looks like it, so the directions tell us to assume it. So because this is a point of tangency, this becomes a right angle. So in terms of a triangle sum, a whole triangle is 180. Take off that right angle, and we have 90 degrees left over for x and 38. So if we subtract off 38, our missing angle is 52. This next picture is not big enough, so I really blew this thing up. It says if it looks tangent, it is. So I'm going to make this our point of tangency, which makes it a right angle. And then this 53 degrees is given right here. So a problem like this does show up in the homework, so you really want to pay attention here. I'm going to highlight this little triangle inside. And what do you notice about these two pink lengths? They are a radius. So what kind of triangle is this? Isosceles. So that means the angles opposite them are equal. So this is 53. This angle would also be 53. So then using triangle sum, 253 subtracted from 180 leaves us with 74. And then what we can do is focus on this other larger right triangle. And the angles here are 74, x, and then 90. So then we can use triangle sum again. From 180, we're subtracting off 74, we're subtracting off 90, and that ending angle is 16. Let's get another theorem in there. If a line is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. I'd say this is the converse of what we were just talking about. So if we have a right angle, then it is tangent. So here's what the directions are going to look like. What is the radius of each circle? Well, we know this is a 90-degree angle, so if that's true, then we know that that's a point of tangency. So what we can do is set up Pythagorean theorem. So here's what Pythagorean theorem looks like. A squared plus b squared equals c squared. Remembering that c is the, you got it, hypotenuse. It is always opposite the right angle. So looking at this question, which number is the hypotenuse? Kind of a trick question because this whole blue length would be the hypotenuse. So setting this up, our two legs would be x squared and 12 squared, and our hypotenuse is the quantity x plus 8. And here comes the reason for our warm-up. This is really x plus 8 times x plus 8. So we have to multiply this out. So we get x squared, our insides and outsides are going to give us 16x, and then multiplying the 8 and the 8 gives us 64. Our goal is to solve for x. So we need to get the x's together. So I'm going to subtract them, these x squareds, and they end up canceling off, which is good news. So then we have 144 is equal to 16x minus 64. So then we can do 144 and add the 64 to get 80. Excuse me, 144 plus 64 to get 208. Divided by 16 leaves us with 13. I hope you're catching my mistakes because I'm doing that wrong on purpose. So what we're going to do is we're going to add 64 but my mistake is this was a positive 64, so that should be subtract. So that should have been 80. So dividing by 16 leaves us with a 5. So then the radius is 5. Pause the video and try the second example. So I may have went a little overboard on how much work I show, so please be aware of that. So multiplying that out, my insides and outsides add to 12x. So we end up subtracting off the x squared, and we're left with 100 equals 12x plus 36. Subtracting the 36, dividing by 12, and x is equal to 5 1/3. And we've been talking about improper fractions, so we'll leave it as 16/3. So we aren't really using that theorem. We know it's a right triangle, so we don't need to assess whether it's tangent or not. We're just using Pythagorean theorem. Moving on to the next set of directions, it says, is ML tangent? So we're technically testing to see if this is a possible right triangle. So if this is a point of tangency, it forms a right angle. So setting that thing up, legs are 4 and 7. We're testing to see, is that equal to 8 squared? So we get 65 compared to 64. That is false. So no, that's not a point of tangency because Pythagorean theorem is not fulfilled. The second example, again, here would be the point of tangency. If it forms a right angle, then it is a tangent. So my legs are 7 and 24. Double checking if that equals 25 squared. For 625, adding that on the calculator, and that is 625. So yes, this is a point of tangency. The reasoning, because Pythagorean theorem is fulfilled, which makes the point of tangency a right angle. Here's the last type of example that we're going to look at today. Theorem 12.3. If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So point B happens outside the circle. It hits a tangent at A, it hits a tangent at C. What's going to happen then is that these lengths are going to be the same, which we kind of already talked about. So here's another way to word that. If a polygon is circumscribed around a circle, then all the sides are tangent. So what that means is point AB forms a tangent on the circle and it hits D. Point B forms a tangent over here at point E. Because that happens, these two things are a point of tangency, which makes BD and BE the same. Same thing is going to happen over here, AF and AD the same. So looking at our example, circle O is inscribed triangle ABC. What is the perimeter of that triangle? Well, using the theorems we were just talking about, here is a spot outside of a circle. It's tangent at D and it's tangent at F. So then these lengths are the same. So this would be 10 and 10. 15 occurs here, so 15 would also occur at BE. Same goes for the 8 and the 8. So our perimeter is going to be the two 10s added together, the two 15s added together, and the two 8s added together. So 66 centimeters, because remember, perimeter is just the distance around an object. Try this one on your own. Pause the video when you're ready. All right, so looking at this picture, the 15 is repeated, 17 is repeated, and we know what the perimeter is. So I'm going to call this A, which would be repeated here. So we know we have to add up to 88. So we have two 15s, we have two 17s, and then we have two unknowns. All of these things have to add up to 88. So that brings us to 30 plus 34 for 64, plus 2x has to equal 88. Subtract the 64, divide by 2, and we get 12. This concludes my video.